review of circles. Equations of circles, how do we graph them? How do we move them? So again, this theme of transforming functions, just like if we transformed y equals x squared, right? So if we had our little parabola or quadratic y equals x squared, we had that x minus h squared plus k. The h and k are coming back in how that we move circles. So if we're just given the general formula x squared plus y squared equals r squared, this means that this is a circle with a center at 0, 0. Okay. And a radius, notice it's the radius squared. So if we look at this one, we know that it has a center at 0, 0. But the radius is not 16. The radius is the square root, right? Because this is r squared, so our radius is 4. So I think the easiest way to graph these, obviously with the center at 0, 0, it's there. If I count out 1, 2, 3, 4, all of these radii, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, I can then graph my circle from there. Does that make sense? Hopefully. Okay. So if we then want to transform or move the circle, our general form is x minus h squared plus y minus k squared equals still the r squared. So our h and k are still coming back, but notice the x minus h, that's the same. But now our k is connected to the y, which again it would be if we subtracted at k over to the side with the y. So it would kind of be the same thing. All right, so these now are going to work the same way. If it's x minus, y minus, that's going to be to the right and up. X plus means that then we're going to have a negative, so it would be to the left, and that one would be down. All right, so if we look at just a couple examples of what equations we could be dealing with. So let's say we have x squared plus y minus 7 squared equals 9. Okay, so again, our x squared, nothing was done with that, so our center's at 0. Our y minus 7 means that we have now moved our circle, the center of our circle, up 7. So now our center is at 0, 7. All right, what else do we know? Well, over here, our 9 is actually our r squared, so we're going to have our r as 3. So if we take the square root of 9, we get 3. All right, so then all I have to do is when I go into graph this, I go to 0, 7, say it's right there, and then I count over 1, 2, 3, up 1, 2, 3, left 1, 2, 3, down 1, 2, 3. There's my beautifully drawn circle, and you're done. Okay, so that would be if you're finding the center, finding the radius, and graphing it. But what if you were given just the information like the center is at 4, 9, and it has a radius of 6? What would that equation look like? Okay, so again, it's x minus h squared plus y minus k squared equals r squared. And yeah, I tend to write the formulas a lot, and I guess that's how I remember them. All right, so these are both positive, so it's not going to change the sign in here. So I'll have x minus 4 squared plus y minus 9. Again, that's squared. And our radius squared, if our radius is 6, then our r squared would be 36. And that is your equation for a circle with a given center and a radius All right, but what if it's kind of, I don't know, a little bit uglier? Maybe not so ugly, but what if our center is at 1, 0, and our radius is the distance of the square root of 15. Okay, and again, the square root is going to be positive because our distance is always positive. All right, so again, this is going to be x minus 1 squared. The y, nothing's done to it. It's still staying at 0, so just y squared. But remember, if I take square root of 15 and I square it, that square root and square cancel out, so I just have 15. All right, but let's do one last one that's got maybe some negatives in it. So what if I have the center where the center's been moved to from 0, 0 to -7, -3, and my radius is 13. All right, so now instead of having the x minus h, it's going to be x minus -7. Yeah. So I can automatically say that's x plus 7 squared plus y minus -3, so plus 3, squared equals r squared. 13 squared is 169. And there you go. So it's a lot of like transforming functions that we've done previously. And I kind of think of it a little as a Pythagorean-ish theorem, of course, with the a squared plus b squared equals c squared. But just keeping in mind that it's x minus h and y minus k, and how those would be affected if our center was negative, and the negative coordinates, like our last problem. All right, enjoy. Have a great day.